Thanks for coming, everyone. Today I'm going to be talking, this session I'm going to be talking about a topic which is close to my heart, behaviour-driven development. My name's John Smart, if you don't know me from other talks or whatever. I come from Sydney, Australia, where I help organisations out with the technical side of agile development, so things like continuous integration, continuous delivery, test-driven development, behaviour-driven development, test automation, that sort of thing. And today I'm going to be talking about behaviour-driven development in the broader sense of the term. Who is familiar with behaviour-driven development? Everyone, good. Who practices behaviour-driven development? A few, that's great. So I'll be going through what behaviour-driven development is about, at least from my point of view. And then I'll be taking you through some of the tools and some of the techniques that can help when you're using behaviour-driven development, right from requirements analysis right down through to development and acceptance testing. So as we'll find out, behaviour-driven development is not just a development practice, it's actually something that can be applied right throughout the development process, which involves virtually every member of the team. So behaviour-driven development, there are a few key concepts that come across fairly frequently. One of them is the idea of a common language between developers, BAs, testers, customers, users, whatever, everyone in the team really, a common language that helps make sure everyone is on the same page really. So it helps ensure that if you're talking about a client in your specifications, when you're actually implementing the code, you're still talking about a client, you're not talking about a customer or a person or a user. And little things like that can make a big difference. Sometimes this can involve also writing a sort of a dictionary, which is a fairly old concept, data dictionary, where you actually describe the terms that you're going to use in the domain language. So it's somewhat related to domain-driven development, if anyone's familiar with that concept. Very simple concept, it's all about communication. So as in a lot of aspects of agile development, this is about opening up communication channels in the team. Another really key concept is that in behaviour-driven development, both at the acceptance tests and at the unit test level, you don't actually write tests. I like to annoy people sometimes. I'll say I don't actually write tests for my classes, but my classes get tested anyway. That annoys people. Because I don't write tests, I write specifications. So they just happen to be implemented as tests. Just so happens that writing an automated test is a really convenient way of writing an automated repeatable specification document. This is really applicable for acceptance tests, very true of unit tests as well, as we'll see. So behaviour-driven development is about specifications. You are writing specifications, but you're not writing them in the traditional 100-page Word document format. You're writing them as something that can actually be executed and verified at each point, and that will produce what we call a living documentation, a living document that describes your system. We'll have a look at some tools later on that can help produce this living documentation. So reports that take your specifications, execute the tests, produce a documentation of what your features actually look like when they're implemented in the system. So that's really important. Another aspect is structuring your requirements in such a way that they can be easy to navigate and document. So it's not just a matter of having a whole list of Cucumber or JBehave stories in a single directory. You need to be able to structure things a little bit better, otherwise it becomes a huge mess. Behaviour-driven development, I think Dan North talked about it being an outside-in something, something, something. Outside in means that you're starting from the user experience and you're working inwards. So when you do behaviour-driven development, You're thinking in terms of what the system is supposed to do, what goes in and what comes out, because what's really important, what delivers value in a system? It's what comes out. It's the outputs. So it's only very rarely do you come across a case where the way you input data adds business value to your application. Users don't necessarily get business value out of the way they input data. It can add business value by making it easier for them to input data, but what they're really interested in what the system does with the data. In most business applications, maybe games would be an exception, but in most cases, what you're interested in is the outcome. And on the other side, the users aren't going to be interested in what happens inside. They're interested in what they do to the system and what comes out. So what do you want to test when you demonstrate to a user, hey, this feature works? You want to demonstrate what the user does and what the system produces. So it's very important to think in terms of inputs and outputs, not in terms of implementation details and what happens under the hood. It's all about value. So we're all about trying to figure out where the value comes from when you implement a feature. When you implement a system, what features are you going to try and implement to get the most value out of the system? So this is taking BDD into the requirements analysis space, where you're trying to figure out, you've got a certain number of features, which ones do I have to implement? Which ones should I implement? If I've only got a limited amount of time and resources, what should I do first? So BDD is not just a development practice, it actually spreads out into the requirements analysis space as well. So in a nutshell, why do I think BDD is so cool? It's all about a lot of things. Better communication, less waste. So eliminating waste, that's a really important one. I've seen a few studies that come up with figures along the lines of, if you have an application that you develop, you write a whole stack of specifications and you write 1 million lines of code to implement those specifications. It turns out that roughly half of the specifications will never actually be used. I'm a developer, I don't care. The BAs wrote all these specifications for nothing. No, I don't care. BAs might care. No, seriously, that's waste for the business analysis side of things. But what's more interesting from a developer's perspective is that half of the 1 million lines of code that you wrote are never actually executed in production. That's kind of more annoying. I mean, you could have been at the beach instead of writing those 500,000 lines of code. And I've seen those results in several different independent studies, so it seems to be fairly consistent, even the figures to a couple of percent. So traditional project approaches produce an enormous amount of waste. Another study I saw recently came out with projects using techniques like this. Well, it was TDD and acceptance test-driven development and agile practices like that. You'd think that you'd have to write more code because you write more automated tests. That's true, but nevertheless, these projects were delivering 30% faster than traditional projects, and with 4 times less bugs. So, less waste is a really important thing. And where does reduced waste come from? It comes from improving communication within the team, improving traceability so that you know why you're implementing any given feature, right from the high-level features down into the details. Every line of code, you know what feature you're trying to implement and what value is expected to come out of the system from that feature, which allows you as developers to make judgment calls when you're implementing features on the best way to do that. And allows well, encourages BAs to get away from the more traditional approach you see in a lot of big organisations where the specification documents will be so detailed that they will actually describe the implementation, which again is waste. And the end result is also, incidentally, it's sort of almost a side effect. You get really well-tested products because you have all these very effective tests. So you get very high code coverage, but I don't use code coverage as a metric to aim for just to have a high code coverage. I use code coverage as a negative metric. If there's a low code coverage, I'll look into it. But when you do this sort of approach, you get very high code coverage very naturally. But it's significant high code coverage. And if you can generate reports to figure out not only what code has been tested, but what features have been tested and how many features have been tested and implemented. So not just in terms bottom up, what code has been tested, but what features have been implemented, top down. So on the, I love these transitions. On the business analysis side, is everyone here a developer? Or are there any testers or BAs or non-developers out there? This is nevertheless interesting to get a picture of the global, so the global view of things. So typically a project, you're going to have some sort of goal to implement, yeah? A project has a goal, high-level business goal. So the terms are a bit fuzzy here, depends on your methodology and your whatever's in fashion this month, but generally you can talk about things like capabilities, features, often in agile projects you'll be talking about stories as well. You have some sort of breakdown of the requirements that support those goals. So a requirement, the point of a requirement is to satisfy the business goal of the application. So the business goal is a very high level concept and all of your features are supposed to support them. Now when you're doing behaviour-driven development in the broader sense, or more specifically what's known as acceptance test-driven development, or example, specification by example is another term, you start from examples of how the system works. So you don't start from vague specifications, you start from concrete examples. You ask really dumb questions like, okay, so you want to build a payroll system, what sort of employees do you have? Do you have employees that work for, give me an example of an employee that works for a department. Give me an example of an employee that works for more than one department, and so forth. So you try and come up with concrete examples of what you're supposed to implement and how the system's going to be used. And those examples become the acceptance criteria. More or less, pretty much a direct correlation between the examples you use. We'll see examples of this later on. This is just a high-level overview. See, examples become the criteria that decide whether you actually implement a feature or not. So at the start, when you decide you're going to implement a feature, you'll come up with a list of acceptance criteria, very concrete cases that the testers and the BAs will say, okay, if the system does this, then I'm happy it should work. That doesn't mean you're going to not test other cases, but it means that that's a general example of what the system should do. So start off with a general, very high level vision. So this is actually based on some real projects. So online classifieds web. This is a client, they're a big media company. Got lots of newspapers and whatnot. They do classifieds ads in newspapers, which is a bit of a dying industry, so they want to convert all that to online classifieds. So one of the things you do with behaviour-driven development is you come up with a vision and then you come up with goals to define the vision. So for example, we've got a goal, you want to increase advertising revenue by making it easier for people to sell stuff online. So that's your goal. Then you might come come up with the idea, okay, well, it's going to make that goal achievable, to make it easier to implement, we're going to make it easier for people to find ads. So that's a feature we want to implement to support this goal. So these goals are funny things. They're pretty simple. A goal is very high level, and you can recognise a goal, at least in commercial organisations, you recognise a goal because it's got something to do with money, as a rule. So a business goal that in terms of the features you're implementing, your high level goal is going to either increase revenue, reduce costs, protect revenue, or possibly avoid future costs. So, very fundamental business concept. If you're anyone working in public organisations, government agencies are a bit different. They don't know about profit. They do know about, say, cutting costs, though. That's a popular one. And value in public organisations can be defined in other terms other than money. So there's the concept of public service which comes into play. So what service are you providing to the public, and how can that provide value to the public? So that's a similar concept when you're in a non-profit organisation. But in any business organisation, it's typically about increasing revenue, reducing costs, or protecting revenue. So avoiding future costs is a variation on those as well. So if your goal doesn't have something to do with, if your feature doesn't map back to a goal that has something to do with one of these general goals, you probably want to think carefully about why you're actually implementing it. So that's really important. Now the interesting thing is that when you ask your customers what they need, they won't think in terms of increasing revenue or reducing costs. Not all of them. Some will. If you ask high-level executives, they'll be more at this level sometimes. Sometimes not. They should be more at this level. But if you ask a customer, you'll often get very concrete requirements. Does this ring any bells? You ask customers what they need, they'll say, okay, I want a red button here, and when you click it, it'll come up with a PDF that prints itself automatically and then sends an email to Joe over there. So they come up with really concrete requirements. So the trick here, when you're doing this sort of approach, is you have to basically keep asking why until you get to one of these business goals. So you get to something that's to do with money. So you keep trying to, the term that some people use is popping the why stack. So you keep asking why until you can figure out what the actual value that you're trying to get out of the system. So here we've got our fundamental requirement is, well, what they're asking for is they want to be able to search by keyword. So you go up the stack, eventually you'll figure out that it's actually the core requirement is that you want to keep earning money by encouraging people to put ads online. So it's quite indirect, but from that you can say, okay, that's the core motivation. Sometimes there are several motivations for a feature, but that's the core goal of this feature. And that gives a perspective, that gives a context of the best way to implement it. So when you do this, you can get ideas of other possible ways that might be better to implement to achieve a particular goal, and you can push back and ask, hey, maybe we could also do it this way. Because one of the problems with implementing what the user asks is that's usually not what they need initially, because the whole development process is an ongoing learning process, and it does take some time to figure out what exactly you do need. So that's just the high-level business analysis side of it. It's a technique that some people call dependent feature injection. You might hear that term around. Anyone heard that term? No. That's a term, general term that describes this approach. Now, getting closer to the actual code, got this, you're going to come up with features in the generic sense. A feature as in a requirement that you need to implement. So a requirement, here we've got a feature, let's get more sales by making the ads easier to find. So from that requirement, we say, okay, our goal is to make it easy for people to find ads online so that the sellers can sell more, so that the sellers will post more ads with us so that we can earn more money. That's so we can trace it all back to our business goal. You always want to be able to trace stuff back to the business goal. So from here, we'll come up with a few features. So we've got notify potential buyers if there's a new item that might be interesting they might be interested in. Be able to search for stuff. Do you want to search by keywords or tags or full text? So there might be different things you could do, different features you could implement to achieve those goals. And it's a judgment call to know which features are going to provide the most value in terms of the goals you're trying to deliver. So the idea is if you have a good picture, a clear picture of what the business goal that you're trying to achieve is, then it's going to be easier to make a judgment call to say, hey, this feature is sort of going to help, but this other feature over here is really going to help, so we'll do this one first. So the idea is that you're going to have a set of features, a minimal set of features that will allow the business to achieve the goal that you're trying to achieve. And then some other features will be more marginal. So there'll be a diminishing return on the features that you implement. So this is fairly typical of any agile projects. Are people familiar with this format, the in order tool? Who uses that format for requirements? Yeah, quite a few. So often you see it the other way around. You'll see as a seller, I want buyers to be able to blah, 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 so that I can increase sales. I find it more effective to use this approach. You say, in order to increase sales. Then you say, as a seller. And then the actual feature comes at the end. So why do we do that? It's because you want the emphasis to be on the goal. The goal is what you're trying to achieve. The person, the seller, the role is pretty much secondary. So this is how you describe your features using a BDD approach. And now features can be at several layers. You can have several nested features until you get to something tangible that you can implement. So you're going to come up with different stories or examples that will help you implement these features. So we might come up with searching by keyword and location. We might say, hey, we want to search by keyword. What's an example of someone searching by keyword? And someone might say, well, my cousin Sally wants to look for a puppy online. And so they'll go through that example and say, yes, but if they find a puppy that's 1,000 kilometres away, that's not going to be much use. So maybe they only want to find them in the city where they live. So maybe they want to be able to search by keyword and location. So you work through these, come up with examples and come up with features to support, or low-level features to support the examples that you work through. So it's the fact that you're working through concrete examples that lets you tease out the features that you need. It's not the other way around. If you come up with sort of general abstract features and then implement them, often you miss things and you have to rework them afterwards. What I find is that if you start from the examples and you work outwards and you say, okay, well, here's this example, but what happens if we do this? Come up with maybe another feature that you need to support this other example. You can work your way out and discuss concrete examples and ask questions. You'll come up with something a lot more concrete than if you try and imagine more abstract features. That's sort of the fundamental concept behind this whole BDD approach, the high level anyway. So when you're coming up with these features, you can either just find them in this sort of story notation, given when then, so given Sally wants to buy a puppy for her son, when she looks for puppies in the pets and animals category, then she should obtain a list of ads for puppies for sale. And sometimes you might want to make that a little bit more general. So what's often used is this table format where you have more a data-focused approach, a data-driven approach, where you have a set of inputs and expected outcomes. So here we've got, given Sally wants to buy a present, when she looks for the present, then she should obtain a list of matching ads. So this is a more general expression of our requirement, but then we have a whole lot of concrete examples of how that would work. That's really good for anything to do with numbers. So anything to do with calculations, that's really useful, this sort of approach. So both approaches are quite common, and you can use both. And so these become your acceptance criteria. These are what validate the features. These are what demonstrates to everyone that the feature has been implemented. Doesn't mean it doesn't have to be tested afterwards, but it means that you've implemented what everyone thinks needs to be implemented. So as I was saying, you come up with all these features, but it usually isn't enough just to have them in one massive list of features. You need to structure them a bit. So often, in the simplest case, you can just structure them in a directory structure. So here we've got a few high-level requirements. We've got post ads, purchase ads, view ads, and so forth. Inside view ads, we've got search for ads and view details. And then in search for ads, we've got a few stories, which are the more concrete cases, searching by location, by keyword, by category, and so forth. So this is just a way of structuring them. So fairly arbitrarily, here I'm using the one structure. We call the top level capability, then we talk about features, then we talk about stories at the lower levels. Now there are variations on that, and it's not particularly important. The idea is that you're going to have some sort of breakdown, some sort of structure in your requirements. So of course they don't have to be in a directory structure. There are lots of places you can get requirements, but when you start thinking about storing them, you want to think about how you're going to structure them. Otherwise it tends to become a fairly humongous mess. So that is what I wanted to talk about just from the business analysis and structuring side. So BDD actually starts way before you do any coding. But now we get to the fun stuff. So now what I want to talk about is some tools that support these. Now, there are people who will say that BDD is independent of tools, which is true, but I would say that if you don't automate your tests, you're losing a lot of the value of BDD because you don't get the automated validation, the executable specifications. There is value in that business analysis exercise of figuring out your requirements in that sense, but there's also a lot of value in actually automating the specifications, a huge value, in fact, automating the specifications once you've got them defined. So, does that do that every time? Anyway, so I'll go through a few. This is a Java conference. I'll talk about some of the more Java-centric tools. There are heaps of them out there. First one I want to look at is JBehave. Who is familiar with JBehave? Not quite a few people. Who's used JBehave? That's cool. So JBehave is a fairly old framework. It's been around for a while. It's been fairly actively developed. In JBehave, you define your stories, a story with acceptance criteria in a .story file. So here you can have a narrative section, which is optional. I like to put it there because it gives context. And then you have these pretty much exactly the same text as we saw earlier on. So given Sally wants to buy a puppy and so forth. So given when then. You can also have the data-driven approach that we saw earlier on. So have a set of examples. So given Sally wants to buy a present and so forth, she should obtain a list of ads for the expected for expected for sale. So here we've got the present, the category and the expected. So you get different values being tested. So from there, JBehave is a Java framework, so you automate it in Java. So you start off with your story file, and then you implement that in just a normal Java Pojo with some annotations, given, when, then. JBehave matches the text that you put in the given annotation, the when annotation and so forth, and to figure out what method needs to be run at each stage. So it's quite sophisticated. You can put variables in the given, when, thens. You can put wildcards and so forth, pass in parameters into the methods. It's a very rich and fully featured framework, so I'm just sort of scratching the surface here, but just to give you an idea. Now, the disadvantage of JBehave is it takes quite a bit of setting up, so there's a fair bit of code you need to write just to get it running. So that's just an example of the sort of code you need to run once for your application to get all the tests running. And it's a very flexible framework, so there are heaps of things you can do, but it can be a bit overwhelming at first. What I tend to do, we'll be looking at a framework that I use on top of all of these frameworks called Thucydides, and that makes it a little bit easier because it reduces it to a one-line class, which takes care of all the details for you. And when you do that, you can, well, we'll see the results later on, but I find JBehave quite effective, quite a nice way to work when you're starting off with a project. If you're trying to add this sort of stuff to an existing project, so you can do it in JUnit as well, that works, but it's a little bit, you don't get all that nice, the nice given, when, then structure for your requirements. So, Cucumber, who's used Cucumber? A few? Yep, so Cucumber is very, very, very similar to JBehave, almost indistinguishable in fact in a lot of ways. The stories are in files called .feature as opposed to .story, but the syntax is pretty much the same, almost. Yeah, or on this side, on the story side, it's pretty much the same. So, you can also have tables, so that's pretty much the same as well. And then there is, as of recently, a JVM implementation of Cucumber. So, which does things a little bit differently to JBehave because it's more recent, so it's a little bit more annotation based, very JUnit centric. So you've got, it looks basically a JUnit runner, so run with Cucumber, and then you provide some Cucumber options. And then the implementation looks pretty much like the JBehave one, except it's got lots and lots of regexes. So you have to like regexes. If you're a Perl developer, you'll be really at home here. So that's the big difference. I actually prefer the JBehave notation because I don't like regular expressions very much, but that might be just me. As far as functionality goes, they're very close, very similar. So the third BDD tool at the acceptance test level that I wanted to look at is one called EasyB. Who uses Groovy? Yep, a few. So this EasyB is a Groovy-based framework. So the big difference with EasyB and the other two frameworks is that in JBehave and Cucumber, you have your story file where you provide your executable specifications, and then you have a Java file that actually implements them. In EasyB, you have both mixed together. So here you have your story file, effectively. That's a DSL, a Groovy DSL, so the syntax is a little bit more complicated than just the plain text file you get in JBehave or Cucumber. And you can do data-driven stuff, but it's a bit clunkier. And then the difference is that when you actually implement it, it's code that you put inside the story itself, as opposed to in a separate file. So here we have the given Sally wants to buy a puppy for her son and so forth. Inside you put curly brackets, a closure, and then you put the code that actually implements that test. So some people like that, some people don't. Sort of depends on your the nature of your test as well. One disadvantage is that this can get quite complicated and it lacks readability. So you're limiting the how accessible this is for non-developers. Whereas when you're doing JBehave or Cucumber, your specifications remain in a very pure text format. On the flip side, you're only storing the specifications and the implementation in one place, so it's easier to keep things coordinated. Yes? When you run both Cucumber and JBehave, if there is not an implementation, it won't generate it, it'll print out the Java implementation that you'd have to write. So that's for both Cucumber and JBehave do that. So you don't have to write the vector. That's a good point. When you execute, you write your specification and you run it, and it will print out the methods that you need to implement any missing steps. So you may or may not use them. You usually use them as a starting point and then maybe insert your variables and whatnot. The fourth tool I want to talk about is a tool called Thucydides, which is a tool that we use and that we lead the development on. It's, don't worry about the pronunciation, just think of two CDs and it's more or less close enough. It's a tool that sits on top of BDD frameworks like JBehave, Cucumber, EasyB, and it also works with JUnit as well. And what it does is it helps structure your requirements. And the reason it's called Thucydides is that Thucydides was a Greek historian. He was the first historian who actually participated in the events that he wrote about. So he was involved in a big war between two cities in Greece, Athens and Sparta. He was actually a general in that war, and so when things were going on and people were speaking and there were battles and whatnot, he took notes and then he wrote it all up afterwards. As opposed to previous historians who said, oh, I heard a traveller who said there were some dragons over in that country over there, so I'll write that down. So the idea of Thucydides is that it observes your tests as they get executed and it reports on what actually happened. As opposed to saying this is the specifications, it actually says, okay, here are the specifications and here's what happened when it actually got executed. So what it does is it observes your tests and produces reports about what actually happened. So you get aggregate reports of how many requirements are actually matched to executable tests. The tests were executed, how many tests were pending and so forth. And then you get detailed story reports. We'll see later on with screenshots and whatnot if you're doing web tests. So in Thucydides, it works with, you saw those given, when, then annotations in JBehave and Cucumber. It works with them, but typically what you'll do is you will add a separate library where you have your own more detailed steps. So here we've got, given Sally wants to buy a puppy, when she looks for keywords and so forth, inside each of those very high-level steps, you have a certain number of actions, some things that happen. So you don't want to put all the page interactions here. You don't. A good takeaway here is when you're writing acceptance tests, make sure you're very careful about your levels of abstraction, because if you have an acceptance test, it's very, very common in all the tutorials you see. An acceptance test, you say, okay, given the user wants to search for cats on the internet, okay, they'll open the Google page and they'll enter this into the field Q and then they'll click the submit button. You get all that in the top level. You don't want that in a real acceptance test. You're mixing levels of abstraction. It makes it really, really hard to maintain. This is the what. This is what should be happening. So you don't want any details about how it's being done. So that's the point of making a layer of abstraction here. So we've got this class called buyer, which represents what a buyer can do. So the buyer chooses category and keywords, then performs search. So that's a very, very simple example, but often you'll have maybe more steps than that. And then in these details, there you actually talk to the page objects. Who's familiar with page objects? So page objects are a technique that you use in web testing to encapsulate your web page behind a class that gives a sort of a DSL that describes basically how users interact with the class. So you don't expose IDs and CSS selectors and XPath and things like that outside the page. Any code that talks to a page is within a particular class and all the details are hidden there, so that if that page gets changed, you only have to update it in one place and all the other tests remain stable. Now this concept takes that a little bit further. So you have the concept of steps for a particular role or a particular functionality, or depends on your application how you group the steps, but you have a set of steps and those steps will contain calls to page objects, so interactions with pages. So the thing about this is it makes it really, really reusable. So it might take you 2 or 3 hours to write a first test, then it'll take you 15, 20 minutes to write a second test, because you're basically reusing steps and page objects and putting things together like Lego. Makes it very, if you write them with proper levels of abstraction, it makes it very easy to reuse and very easy to maintain. So if something changes, again, it makes it easier to update with a minimum of impact. So that's why we do it this way. So that's what this step annotation is about. So in the reports, so we get this idea of a global report which summarizes all of your requirements. So you've got this concept with these reports of top-down requirements reporting and then bottom-up test results. So Thucydides will look at the requirements that you've defined in JBehave or Cucumber or whatever. Say, okay, you've got all these requirements. I want to see which tests actually map to these requirements. So, and then if you, as I was mentioning earlier, if you structure the requirements in a reasonable way, so you don't just have a list, a massive directory full of requirements, but you also have your features, your capabilities in an organized way, then you can drill down into particular areas and see which features, how well certain capabilities or features are implemented, which ones, how many tests are done for a particular feature and so forth. Makes the reporting a lot more relevant. So here, for example, we've got posting a new ad, nothing's been done at all. So that means no tests have been written at all there, or some tests have been written and they're all pending, but it can also mean that there are no tests. You've said, here's a requirement that we need to implement, but we haven't done any tests. Whereas the search for online ads, we've got some tests that are passing and some tests that are pending, or maybe some requirements that have not been tested at all. So this idea of, it's sort of like code coverage, but it's not to do with code, it's to do with features. It's feature coverage, if you like. Now it takes your requirements and figures out what tests actually work for those requirements. And that's really powerful, because you can come up with a very good idea of progress in a particular sprint, get a reverse burn down chart, you can get an idea of how far you're progressing. So it's taking the test reporting a lot further. So here, for example, we've got a list of the capabilities of a particular application. Then we might drill down into a particular story, find the acceptance criteria for that story, and then, as I was saying, in the story, you'll have, okay, given Sally wants to buy a puppy for her son. So she opens the home page, she chooses region, chooses categories and so forth. You see exactly what was done to test a particular feature. So the testers really like this, because they can say, okay, you developer folk, you say that you've implemented this search feature, so I'll have a look at these tests and see what it actually does and whether I'm happy with that. And then the tester can go and test that in more detail or try and break it, basically. But it saves a lot of time, gives a much clearer picture of what has actually been implemented. And yes?
So those screenshots that I see there, one more than captured, one more than captured.
So those screenshots are captured it's something you configure, but what I typically do is configure it so that the screenshot is captured every time a button gets clicked or something gets entered into a form. So you can see it's as if you're watching the user filling out a form and then clicking buttons. If you want it to be a bit more succinct, you can tell it to take a screenshot at the start and the end of every step. But I find it more interesting to do it on every interaction. So yeah, the screenshots basically tell the story of what happened during as it was played. You can also, so you also see as it goes, you get the textual description of the step that was being played out, so you can get some context of what's going on. So that's what I wanted to talk about as far as acceptance testing goes. I also want to talk about BDD from the pure development point of view. So you've got your acceptance criteria, you know what you need to implement. Typically what happens then? So, yeah, what happens then? So you got maybe some screens you need to implement. You know that you need to implement a particular screen. Maybe you've got a UX person who'll come in and figure out how the screens should hang together, and a designer and whatnot. At some point, you're going to say, okay, we've got these screens that we need to implement, but we need to make them do something, so we're going to have to implement some code under the hood. So that's where the developer side of things comes into play. So here we talk about the distinction between TDD and BDD. So who practices TDD, test-driven development? Yep, quite a few people. Cool, isn't it? So this is, what I'm doing here is, I want to distinguish between, well, sort of explain how TDD relates to BDD really. So in test-driven development, classic test-driven development, you write a failing test, you make it pass, and you refactor and you loop on that. Yeah? That's TDD. The question is, how do you know what tests you want to write? And that's something that often in the examples, it's really hard to figure out, okay, they come up with this test, where'd it come from? I mean, it's okay if you're doing a stack implementation or something, but for real code, that's a bit trickier. The answer is it comes from the acceptance tests or the level above. So your TDD is your low-level features, and your acceptance tests talk about more high-level features. So at each level, you have different tools that you can use. And the idea is that your acceptance tests give you a list of specifications of what you need to implement at the lower level. So the first, you're going to have some specifications, or you'll have a UI. Then you say, okay, this UI has a list of categories. How do we get the categories? We hard code them, or do we get them from a database or a file or whatever. So there you're going to have to come up with some requirements about how to get those categories. So how to make that web test actually work, you're going to have to look at your service layer, your database layer, and so forth. So you have to drill down a bit and start to think about how you're actually going to implement the lower layers. So at each level, you're going to come up with a test, an executable specification, which is in fact a specification for the next level down. Yeah? So your implementation of a test at one level ends up being the specification for the test at the next level. So you end up drilling down until you actually write some code that does something. So on the way down, you'll be mocking stuff out so that you don't have to, so if you're doing TDD, you'll be familiar with mocking. So on the way down, you mock stuff out that you're not interested in doing at that point in time until you get to the code you have to actually code. You write your code, you work your way up, getting rid of the mocks. So the answer, the question, where do the tests come from? How do you know what tests to write? They come from the acceptance tests. And where do the acceptance tests come from? They come from features that are supposed to provide value. So getting back to that goal of providing value, all about providing value. So any code you're writing, you should have the context of what business value you're trying to implement. So that's very true at the UI level, but even at the database level, you're going to say, oh, okay, is this a database that we're going to be doing a lot of queries on, or are we going to be more doing a lot of updates? Depending on what the goal of the application is, you're going to make certain design decisions. So you have this distinction between your acceptance tests and then taking a bit further your low-level unit tests. And they are very different. So the unit tests have a different flavour to them. They're much more technical. They're not designed for outside consumption, really. They're designed for developers. They're written for other developers, really. They're low-level specifications that you're writing so that the next developer coming along can understand what's going on. Acceptance tests are more for everyone else. So acceptance tests give a vision of where the application is at as far as the development goes, and is everybody happy with what's being developed. So I've got 10 minutes left. I just want to run through a few low-level BDD testing tools. I won't talk about JUnit because I think you're probably familiar with JUnit. I'll just talk about a couple of others that I found useful. First one, Spock. Who's used Spock? Anyone use Spock? A couple of people? Spock rocks. Spock is really, really cool. I like Spock. Spock is a groovy BDD framework. Nice thing about Spock is it's really, really easy to use. And it's very intuitive. So it works for your IDE. It's a JUnit test, so it can run like a JUnit test. But since it's in Groovy, you can do a lot of really nice stuff. So you have this given, when, then. So given we're selling a shirt, when we calculate the price including GST, then the price should include a GST of 10%. So instead of just having a unit test with asserts at the end, you structure your test using the given, when, then pattern that is very, very effective in BDD. And it does change the way you develop at the lower level too, because you start thinking in terms of, okay, what is my expected outcome? So you think in terms of behaviour more than the tests. So it's a really nice way of developing. And it's very intuitive. So you got this, where then the total price should include a GST, and then total price equals 11. You don't need to worry about assert or assert that or whatever. It's much more lightweight, and when you get used to it, it's very obvious what's going on. So that assert, if it fails, it will show what was given and what was expected in great detail. So the reporting's really nice. But just making it makes it very, very readable. Makes it easier to write tests more quickly, faster than just plain old JUnit. So if something goes wrong, you get something like this, a little description of, okay, this didn't work and what was happening on each side of the equation. You can also, so if you're doing TDD, you're probably familiar with mocking frameworks, like Mockito, EasyMock, things like that, yeah? In Spock comes with its own mocking framework, which is a little bit weird to start with, but it's really, really powerful and quite intuitive once you get used to it. No, it's not very precise, is it? It's easy to use once you've learnt it. So here we've got, for example, get rate, thingy, 0.125. You're basically mocking out, you're creating a mock GST rate provider and saying that when you call get rate, it's going to produce 0.125. That's all you have to do. And then the rest just happens. So it's really, really lightweight. It's even more lightweight than Mockito because there's less to type. So you can also do mocking in the sense of mocking as well. So here we're saying, okay, we're expecting, so what are we doing with sales? We're selling a sales When we sell a shirt, we expect that the delivery service should have been called once. The dispatch method on the delivery service should have been called once with any parameter. So you can do also a lot more complicated stuff than that. You can even put closures and stuff like that. But the point is, it's really, for simple stuff, it's very lightweight, and even for more complicated stuff, it's very concise. So it makes it easy to write tests. And another really cool thing is the data-driven side of it. So we saw those table-based examples in JBehave. You get something very similar in Spock. So here we're testing a library that converts a single form of a word to plural form. And so to test that, I've got a whole lot of examples of words being converted from single to plural, or from plural to plural in a couple of cases. So when you look at that, it's very easy to see what's going on. In JUnit, you'd have to do a parameterized test, which always puts me off a bit. So that's Spock. I would highly recommend playing with Spock if you're doing even just TDD. It's really, really worthwhile. If you're scalaing, anyone use Scala? Okay, I'll skip this bit. This is pretty much the equivalent in Scala. It's a library called spectool, and it's sort of like Spock but with Scala syntax. So the syntax is kind of weird, but if you're working with Scala, that won't put you off. So it's very, very similar. It's just you've got funny symbols in more places than in the Groovy version. So you can also do, what's the difference? It's very, very similar, really. I'd say I prefer Spock, because Spock I find more immediately readable. But if you're doing a Scala project, then this would make perfect sense as well. So and you also get the data-driven stuff. Again, funny symbols all over the place, but I mean, as I said, if you're doing Scala, I'm used to that. Yeah.
So with Spock, does it assume that it's testing against Java code or Groovy code? Because I know there's some limitations in mocking Java code from Groovy code. Does Spock address that as well?
Yeah, it works really. I know you testing Groovy code with Java mocks is pretty much impossible. Very, very difficult. Spock works well with it. Spock's in Groovy, so it's happy to mock out Groovy classes.
But so let's say for my core classes
Yeah.
Java.
Yeah, any JVM classes. So I use Spock to work with both Java and Groovy. So I typically write all my tests in Groovy. I used to have I've only got 2 minutes left, but this is important. I used to have a philosophical objection on the grounds that you should write your tests in the same unit tests in the same language that you write your code, because they are examples of how you use your code. But writing tests with Spock is just so much easier. That sort of overcomes that objection. So I just try and make sure my examples look like Java code if the application code is in Java, and everything around it is in Groovy. So the last thing I wanted to look at is JavaScript. Anyone do any work with JavaScript? Yep. Anyone use Jasmine? A couple of people? So it's a BDD framework for JavaScript, which is kind of cool. It's simple, it doesn't do a lot, but as in it's got a fairly simple structure. You just say describe some function, and then you create a function. It does something, and then expect. So expect to convert 50F to C to equal 10. So you just build up a whole lot of tests using this expect format. I think the great beauty of Jasmine is that it exists. So it means you can actually test your JavaScript in a meaningful way. You can also do more complicated stuff. If you're good at JavaScript, you can do much more funky stuff than this, obviously, at the testing level, but that's the general idea. You can structure your tests as well, and nice thing, it even works with Maven, so you can actually integrate your JavaScript tests into your normal Maven build, which is kind of cool. That's just some examples of the reports running. So you can have a look at the details on the slides, which will be on my website, on the Java 1 website as well. I think that's all we've got time for, but I think the general message I wanted to get through with this talk is that, in fact, BDD is not just something you apply at a particular point in the development lifecycle. It's actually something you apply right through from the business analysis right through to the development, and also floats back up to the acceptance testing. So it really is something that is applicable right across the development lifecycle. So, questions? Yes?
Having worked on a project with about 7,000 tests.
Sorry?
What was your experience because stories are often written in either text or HTML or tables, that you need to be very tight about the language you allow? Because we found we had 7,000 tests and we found an issue where we make something mandatory, refactor it to 7,000 sort of code tests.
Yeah. That can be an issue. You will, what typically I'll get people to do is when they write those tests, the given when then, they don't just get a BA to go off in the corner or a user to say, okay, write down some tests and we'll see what we can do with them. You work through them with the BA, the user, a developer as well, to make sure that the tests are actually done in a reasonably disciplined way so that they can actually be testable and that they use a consistent vocabulary and whatnot. Yeah, and you've got to refactor things so that you get maybe one test with some data-driven examples. Another thing, when you get testers testers tend to go overboard on the examples. They'll say, okay, we'll enter an age of 10 here, but what if it's an age of 11? Okay, we'll put 10 and 18, but what about 15? And so they'll try and get exhaustive examples, whereas what you really need for the acceptance test is a more high-level overview, some key strategic examples, but not going into the exhaustive depth. If you really need to do the exhaustive stuff, you usually do it at a lower level. Otherwise, it's sort of a trade-off, but otherwise your acceptance tests become overwhelming and hard to maintain as well. Any other questions? Yep. Sometimes, depends how technical they are, but yeah, sometimes they do. Usually it's collaborative though, because the story files are in version control and the customers often don't have enough technical knowledge to actually go and hack around in the version control system. At least the places I work. Sometimes they do, but usually it's collaborative. So the value is not so much that they physically write the text, but they're involved in writing it, and when they see the outputs, they actually see what they wrote. No, Spock is more a unit testing tool. So Spock is not so much focused on the reporting. It's more focused on as a developer communication tool. So when you're writing the given when thens, the actual text given when then is actually optional. But Spock is more to help you express your ideas and specifications in technical terms, but express them in a given when then structure. So it's easy to understand for other developers. Whereas so you wouldn't use Spock for acceptance tests. You use it for unit tests because it's not so focused on communication and reporting. Whereas things like JBehave and Cucumber and whatnot are more focused on the reporting side of things. So they're more heavyweight. Spock's really lightweight, you just do it. JBehave requires a bit more setup, but the benefits you get out of it are in the reporting side of things for beyond the developer team. Yep.
Do you use a couple of BDDs with a continuous integration server?
Oh yeah. definitely always run the BDD test on it. So on each commit, you run your acceptance test on each commit, yeah. You do it as a pipeline. So you run your acceptance tests after your unit integration tests, but each commit will get acceptance tests running.
Prototype was working on one of the projects. They had sort of all the tests run each time, and if someone took in a new test, that was to filter right. So that was, people were really upset about it because it was couldn't run the test before we had a implementation in place because that would break the build.
So that's where you use in pending tests. So you mark tests as pending. So you're specified, so okay, we need to do this, but it's pending until you actually implement it. So in the reports, it won't break the build, but it won't mark it as passing either. It'll mark it as pending. So in BDD, you have this three-state concept, trinary state or whatever. Yes?
Can you comment on fitness?
I haven't used fitness in a while, mainly because I haven't. Fitness is, the big difference with fitness is it's wiki-based. So the users can contribute directly to the tables and the developers have to sort of scramble to write the fixtures behind the scenes. I find it a little bit harder to do the version control and integrate it with the CI and whatnot. I find it easier to have it all in version control, all versioned and managed that way. That said, there are a lot of people who do use fitness quite successfully for acceptance testing. So the fitness has so everything is a table. You tend to get everything expressed as tables, which may or may not suit the way you're doing it. It's also I find it's got the disadvantage of a wiki in that wikis are a great place to brain dump information, but they're terrible for structuring things. It's a little bit too free-form. So I like that. I like being able to structure the requirements so that you can drill down in different features, different capabilities, and know where each capability is at. That's I tend to prefer things like JBehave or Cucumber or that sort of tool. Yes? JBehave has a reasonable, JBehave has a reasonable IntelliJ plugin. I'm not sure about Cucumber, which will actually tell you when the labels in a scenario don't match an implementation somewhere. But the general recommendation is it's an issue. Can be a problem, but if you can leave the level of abstraction fairly high, that can help. So you're not touching the descriptions too much.
I think most of our problem was with the mediation of steps. Different developers have different ways of expressing something, and many steps gradually sensing or slightly different.
So that's where in fact, when you're writing, I was talking about those step libraries with the Thucydides implementation, where you do layers of abstraction. You really need to write the acceptance tests as if it was a part of the application code. So with the same discipline. So you'd be a bit annoyed if 3 developers wrote the same code to do pretty much the same thing in different places in your application. So it's the same thing in your acceptance tests. So you need that sort of reflex to have the discipline to refactor and make sure before you implement a step to check whether it exists already. So it's a discipline coding exercise. You need the same discipline as you apply to your normal code. It really is the same level of quality as production code. Yep. Yeah. So we're just talking about Thucydides because that's what I use the most. what we do is we hook up Thucydides with Jira, for example, so that you'll add an issue number. We'll store the requirements in Jira as story cards, and then there'll be a structure in Jira. Often there's a customized card structure with features and whatnot. So you get a link in the reports back to the Jira card, but you can also set it up so that the test results will impact the status of the Jira card, so that you can, if an acceptance criteria fails, the Jira card will be passed into a failing broken state. So you can get that sort of integration. That's what we do quite often. You could do the same thing where it's just a plug-in, so you can do it with pretty much any issue tracking which has an open API. But it's highly recommended to do that because it helps keep everyone in the loop. Yes?
Do you try to write all of your acceptance test examples for a feature before beginning coding a feature, or do you write some of them and then write the code, do those tasks, and go back and add more?
I try and write as many as I can feasibly, but I'm not fast if I have to add more ones. It's just a question of traceability, so that you get a better. If you're doing Kanban, doesn't really matter. If you're doing Scrum, you want to have a reasonable idea of what you're expected to implement. So it's easier if you have as much possible up front. It's also a question of when you do the examples, you're usually doing them collaboratively with testers and the BAs. You have to actually get them and get hold of them and work through the examples. But it's not a hard and fast rule. You can, as you implement stuff, you'll often think of examples that you need to test as well. And so you might want to add extra cases. So if you're doing the data-driven approach with tables, that's really easy. You just add a new line. Yep.